So there are a couple of different ways to approach problem one. From here, I can use the idea of the sum of the interior angles of an angon, or I can use the exterior angles of a polygon. To use the interior angles, I'm just going to set this up. I would say, well, if it has n sides, I could make n minus 2 triangles out of a polygon with n sides. Each triangle measures 180 degrees, and then I'd have to divide by n to find the measure of one angle, and that is 150. I could then turn this into a proportion, cross multiply, and solve for n. A faster way is actually to use an exterior angle measure, because if this is a regular polygon, then if the interior angle measures 150, the exterior angle measures 180 minus 150, which is 30 degrees. Then I can use the exterior angles conjecture and say that no matter how many sides this has, 1,000,000 sides, 4 sides, the sum of the exterior angle measures is 360 degrees. So 360 divided by 30 is going to give me 12 sides. I would also get 12 sides if I solve this proportion. This is just a faster way to get it. Now, you needed to show your work in order on this one. The first angle measure that I found was A, and I did that by looking at this large triangle. I'm going to highlight this very roughly, and then I'm going to get rid of this highlighting. So I'm looking at this triangle. It's an isosceles triangle because this angle and the measure A are congruent, and this is 58 degrees. So I'm going to get rid of that highlighting now. And my angle is going to be 180. Subtract out the 58 degrees I already know, and divide by 2 because those two angles are congruent, and I get A is 61 degrees. So I'm going to put that 61 degrees in here and remind myself that that is also 61 degrees. Now, I did find B next, but I didn't always go in alphabetical order. For B, I looked and I said, if I look at this triangle, this right triangle, B is actually an exterior angle of that right triangle. The exterior angles conjecture says that the two remote interior angles, if I add those two angle measures together, it's going to equal the measure of that exterior angle. So again, I'm going to get rid of that highlighting. Oops. Get rid of the highlighting. So to find B, I took 40 and added 90 to it. So B is 130 degrees. I did not find C next. I actually found E next. And I found E by looking at this large quadrilateral, the one with the 76 degree angle and the 90 degree angle. Oops. Nope, I'm sorry. This large quadrilateral, the one with the 130 I just found, the 58 degrees, and the 61 degrees. If it's a quadrilateral, the sum of the angle measures is 360 degrees. I just found that the measure of the one is 130. I know the 61 degrees and the 58 degrees at the bottom of the screen. So E ends up equaling 111 degrees. Once I found E, I actually said, again, not necessarily the fastest way to do this. I labeled this Y and this Z. They're congruent to each other, so Y equals Z. And if I notice, this one forms a linear pair with the 130 degree angle. So if they're congruent, then to find each of them, I'm going to take 180 and subtract out the 130 that I already found to find that they both are equal to 50 degrees. And I'm now going to put my 50 degrees in there and here. Once I knew those two angle measures, now I went and found C. So to find C, it's a linear pair with this 50 degree angle that I just found. So C is 180 minus 50, C is 130 degrees. Again, I'm showing my work in the order in which I found the angle measures, and it's work that is not just scratch work. You can actually follow and see what's going on. Once I found that, I made this angle measure X. And I did that because if I look at this large quadrilateral here now, I know this is 76 degrees, this is 90 degrees, and this is 111, and the four together have to be 360. So to find X, I took 360 minus the 111 minus the 90 minus the 76. So X equaled 83 degrees. G equals X because they're a vertical pair. So actually, G equals X was the next thing I used. Since X is 83 degrees, G is 83 degrees. Now I'm going to mark those in 83 degrees, and X that I just found is also 83 degrees. Now, once I knew those, I said that this angle measured down here was V. And V is a linear pair, or actually V is equal to C. So V equals 130 degrees without me having to show any work for it. Just label it. So V is 130 degrees. And the reason that I did this is once I know that angle measure, I made this angle measure W because I have a pentagon here. And if I use the pentagon sum conjecture, I know that the sum of those 5 angles has to be 540 degrees. So to find W, I'm going to take the 540 degrees, subtract out the 130, the 111, the 83, and the 130. So minus 111, minus 2 times 130, and minus my 83. So W equals 86 degrees. Again, putting this in order so somebody could follow and see what I'm doing. Well, the one with measure W is a linear pair with the one with measure F. So F equals W equals 86 degrees. Once I find F, I can now find D. Now, the reason I can find D is that it is in this quadrilateral. Again, I'm going to do this larger quadrilateral here. Oops. Can't draw that very well, and I'm actually going to get rid of it, but that's the quadrilateral I'm talking about. I know 3 of the 4 angle measures. So to find D, I'm going to take 360, subtract out V, which is 130, subtract out X, which is 83, and subtract out the 88 degree angle that I started with up there. And I end up with D is 59 degrees. Once I find D, I needed to add another angle measure in here to help me out a little bit. Oops, and I'm going to put my 130 degrees in for my C. Eventually I want to find H. What I found though was that it was helpful to find this angle first. So P is a linear pair with the 86 degree angle, so it's 180 minus 86, which means P is 94 degrees. The reason I did that, my last outline here, is going to be that I know H is an exterior angle of this triangle, so H has to be equal to the sum of these 2 angle measures. So H is 50 plus 94, which means H is 144 degrees. So I used triangle conjectures. I also used polygon conjectures to get that.